Okay, so here we have a GCSE exam question, a very typical probability question, which will give us a chance to work out which method would be best to use to solve this kind of question. So what we've got is Jack and Lucy, who each spin this fair 10-sided spinner once. And just to give you a chance to look at this, I'm going to now fill in these colours that they've marked in here. So they've just used G, 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 G for green and B, 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 B for blue. If we shade it in, it makes it clearer that there are more greens than blues. Okay? And the other thing to point out is that they've only shown us one spinner, but of course the spinner is spun twice. So we got to imagine two spins of this fair 10-sided spinner. Now it tells us that Jack wins if the colours turn out to be the same, and Lucy wins if the colours turn out to be different. So we're looking at the probability of all the outcomes where the colours are the same, in other words GG or BB, versus the probability of them being different, in other words GB or BG. So who has the better chance of winning, Jack or Lucy? Now before we tackle the question, I want to briefly look at the examiner's remarks, and they were quite simple for this question. Apparently the most successful approach, so they say, was to draw a tree diagram. So we'll have a look at the tree diagram method, and this method, they say, is to do with labelling all the probabilities and then doing the calculations from there. So that was the most successful approach, but it's not the only one, so we'll have a look at the alternative, which is to look at the whole sample space. They also say it was rare to see students who appreciated that it was unnecessary to work out the probabilities of both Jack and Lucy, showing Jack's probability that was more than 50% would have been sufficient. So you didn't need to work out Lucy's probability as well, because they must be complementary, and it's a certainty that you're either going to get the colours, in other words, to be the same or different. So you only needed to work out Jack, and it was really unusual that students appreciated this, and therefore they did twice as much work as they needed to do. Okay, so how do we approach this? Well, the first approach that we ought to think about when we're looking at any probability question is can we calculate, have we got enough time within the test, for example, can we calculate the entire sample space and work simply with all of the possible outcomes to get our answer, or is that going to be far too time consuming, and setting up a model of the entire sample space wouldn't be the best approach? Well, it's not easy to assess that with this situation. We've got a 10-sided spinner. We're going to spin it twice. So that's going to be 10 possible outcomes in the first instance, and then 10 in the second. So it's going to be 10 times 10, 100 possible outcomes. That seems a rather large number. On the other hand, a 10 times 10 grid, since they're the same situation is going to happen in the first event as in the second, so we're just repeating the event. A 10 by 10 grid doesn't sound too unreasonable, so I'm going to have a go at that and see whether that isn't an approach that would be useful to adopt here. Okay, so if we take a grey pencil here and just sketch out a 10 by 10 grid, let's see if we can fill that in. Let's just speed this up. Okay, so that we've got a grid nice and quickly drawn like that. What we can do then is think about our, if you like, our kind of axes, our headings here, our column and row headings. So now we've got the idea of the greens. So there are 6 possible outcomes that are going to be green in the first event. So along our column header here, if you like, we've got greens. So I could write, in fact I will, we could write just G, 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 G. Or, if we think that's a bit too laborious, I think we can just get away with just writing B once for the complement here and just indicating which of these are B. So that works quite nicely as well. Let's use that approach then for here. So these ones here are all going to be G outcomes. This is for the second spin, so it would be up to here. Okay? And these ones are all going to be B. Okay? So I think we can see from that, in fact it's much clearer if I just erase this, I think it will be neater. It's much clearer if I just say these are all G's and these are all B's, that we've got areas here that we can think about instead of just writing out, say, GG, GG, GG. Here we would have GB or BG, let's say BG, and here we would have GB. All of these ones here, though, are going to be BB again. So the area where we've got the same, because that's what we're looking at, is going to be, if I fill it in with a highlighter here like that, it's going to be this area here. These are all going to be GG outcomes. And if I look at this area here, these are all going to be BB. So here we've got, let's use a different colour to make this clear. Here we've got all GG, like that, and here we've got all BB. And again, we don't need to work out these areas here, we just need to work out the likelihood of these spinners coming up the same. So all we need to do is work out the areas here and here, the GG and the BB. That's going to give us the probability of Jack winning. So we can say that the probability of colours, whoops, let me just correct that, probability of colours being the same equals the probability of colours coming up green, green, GG, or, in other words, we're going to add the probability of them coming up blue, blue, in other words, BB. And we can say then that if we know that the number of possible outcomes is 100, because we've got a 10 by 10 grid, the probability of GG is going to be out of 100. So we write denominator out of 100. And the numerator is going to be the number of possibilities of it coming up GG. Well, we've got a 6 by 6 grid here, so we've got 6 times 6 is going to be 36 out of 100, or 36%. The OR becomes plus. Okay? And the probability now that we're adding to 36 out of 100 is the probability of blue, blue, which is again out of 100, our total sample space. And we've got 1, 2, 3, 4 times 4, 16 out of 100, 16%. And then we've got our answer, because 16 plus 36 plus 16 gives us 52 out of 100 equals 52%. Therefore, Jack wins. Well, that answered the question, but we were told that the probability tree method worked well, and the method that people must have used would be this one. So in other words, they set up a probability tree where they were just looking at 2 possible outcomes. Let's draw it like this. So that the probability, they're looking at the probability of green, so we can put that here, versus the probability of blue. This would be our first event. Okay, so this would be the first spin, let's say, first spin. And now we've got the second spin, which we can draw. Again, if I use a different colour, that should make it clearer. We can draw like this. Okay, and again, we've got the same outcomes. We've either got a green or we've got a blue. A green or a blue. So these are independent events, so we don't have to worry about the second event being influenced by the first. Okay, the spinner, when it spun the second time, has no memory of what happened in the first spin, so they're independent events. Okay, so now we can fill in our probabilities. The probability in the first spin of green is going to be the number of greens divided by the number of faces that we've got. Okay, so we've got 6 greens and we've got 10 faces, if you like, edges. So we've got a 6 out of 10, and in fact what we've got here is a visible fraction. So we've got 6/10 of the spinner. Okay, so we've got 6/10 as our first probability, and the complement of that is the chances of it coming up blue. So we've got 1, 2, 3, 4, 4/10, 4 out of 10. In the second spin, we've got the exact same numbers, so we've got 6, 10, and we've got 4 out of 10. By the way, a check here, of course, is to just add these together, and they should equal 1, which they do. And again, we've got 6 out of 10 and 4 out of 10 on these branches here. So we know that the outcomes that we want for Jack are green, green, which is here, or blue, blue. So again, we've got the probability of gigi or the probability of blue, blue. Now all we need to do is our calculations, and we can use these lines here. So we've got probability of green, green. Using the multiplication rule, we just multiply along the pathways. So we say 6/10 times 6/10. Or, to make our calculation easier, we can simplify first. So we say 3/5, so divide top and bottom by 2 times 3/5. And that's going to give us 9/25. Now we need to do the other pathway here. So we've got the probability of blue, blue. And that's going to give us 4/10 this time, times 4/10, or to make our calculation easier, 2/5 times 2/5, giving us 4/25. And if we add these together, we should get the probability being 13/25, which, if we multiply top and bottom by 4, would give us 52 out of 100, in other words 52%. So again, we've proved that Jack must win, and we don't need to prove that the complement of that, Lucy, loses. In other words, she gets 48%, because all we're looking for is the percentage, which of these probabilities rather, comes to more than 50%, and we've discovered that it's Jack, so Jack must be our answer, so this must be correct.